I'm Isha Nur Humaira.
I'm Shafia Mukhlisa.
Hi, I'm Nurani Razali.
Hi, I'm Shazlato Balkis.
And I'm Nurul Izwani Hanis.
In Malaysia, there are three objectives and some significance of our study. The first objective is to identify the estimation of mean, variance and standard deviation of the floodwater level in Malaysia.
Second objective is to identify the association between test of independence of flood area in Malaysia and type of water level.
The third objective is to compare the mean of water levels between 5 different days by using ANOVA.
The significance of this study can be concluded as the understanding of awareness toward the flood water level in Malaysia. This study also can be served as an early preparation which result quick action. This awareness can help people to understand how dangerous the flood water level can be and how to overcome the flood water level to increase. Thus, it can help to reduce the damage to the people's properties.
We will explain the first objective, which is the estimation of mean, variance and standard deviation of east and others in Malaysia that affected by floodwater level. So our focus is to identify the estimation of mean, variance and standard deviation. The following table 1 shows the result of a floodwater level in east and others area in Malaysia. Others area include Kedah, Perlis, Perak, Pulau Pinang, Johor, Sabah and Sarawak. So this is the table 1 that shows the result of water level in flood area in east and others area. The first step is we should calculate the value of sample mean x bar by using this formula. We must add up all the value of x and divide it with the sample size, which is n. So the answer is 55.255. Then we should calculate the variance of the sample by using this formula. We already obtained the value of x bar during the first step. So this is the answer. Next, we should find the value of standard deviation by using this formula, and the answer is 99.9332. When we already obtained the value of mean, variance and standard deviation, we can identify the estimation of mean of flood water level in east and others area in Malaysia. To get the value in this table, we have to use the formula of confidence interval, which is x plus minus t alpha over 2 standard deviation divided by square root of n. We use t distribution since the sample size is small and divided the value of alpha with 2 since it is 2t. So we already get the value of estimation of mean. So this is the conclusion that we can make. Next, we have to identify the estimation of variance and standard deviation of flood water level in east and others area in Malaysia. So first, we calculate the estimation of variance. Since our data is one population, so we use chi-square distribution and calculate the value of degree of freedom and alpha over 2. The first row represent the value of chi-square from the right and the second row represent the value of chi-square from the left. These two values can be obtained from the chi-square distribution table. We should use this confidence interval to estimate the variance. The value in the first row is for this part and the value in the second row is for this part. So we already obtained the value of estimation of variance. So this is the conclusion that we can make. Then we have to calculate the estimation of standard deviation. We use this confidence interval to estimate the standard deviation. It is the same things as I said before, which are the value in the first row is for this part and the value of the second row is for this part. So we already obtained the value of estimation of standard deviation. So this is the conclusion that we can make.
Objective 5.2, the test of independence of flood area in Malaysia and types of water level. The following table show about the area and type of water level in flood area. As you can see here, we have types of water level that consist of warning level and danger level. Other than that, we have flood area which is east and others that include north, south, west and Borneo. So, step 1, in the test of independence, we test the null hypothesis that two characteristics of elements are not related, that is, they are independent, against the alternative hypothesis that two characteristics are related, which is they are dependent. We can say that the null hypothesis is equal to flood area and flood water level are not related, while alternative hypothesis is flood area and flood water level are related. Next is step 2, where we need to select the distribution to use. Because we are performing test of independence, we use the chi-square distribution to make the test. Okay, in step 3, we need to determine the rejection and the rejection regions. With a significant level of 5%, the area of the rejection is 0.05 and it falls in the right tail of the chi-square distribution curve. Then we need to find the degree of freedom to be able to use the chi-square distribution table. If you look here, the formula of degree of freedom is equal to R minus I multiplied with C minus 1, where R and C are the number of rows and the number of columns respectively. So if we refer to the table, we know that the number of columns is equal to 2. Same goes with the number of rows, which is equal to 2. Then we substitute into the formula and get the value which is equal to 1. From the chi-square distribution table, the critical value of chi-square or degree of freedom equal to 1 is 3.84.
Now, we go to the next step, which is step 4. In this step, we will calculate the value of the test statistic. The formula for the expected frequency E for a cell is calculated as row total multiplied with column total, then divide by sample size. As you all have seen the table about the area and the types of water level in flat area, in step 1, we can calculate the expected frequency E for each cell. E for ease and warning level is 40 multiplied with 25 and divided by 51 is 19.6078. Next is for ease and warning level, which is 11 multiplied 25 and divided by 51 is 5.3922. This formula continues to calculate E for ease and danger level, which the result is 20.3922, and E for others and danger level is 5.6078. We also can calculate with software such as Jamovi, and the result will come out like this contingency table. With all the information that we have calculated, now we can calculate the value of the test statistic. The formula that we are going to use is as in the slide, which is the sum of open bracket observed frequency minus expected frequency close bracket square and divided by expected frequency. After that, we will get 1.199, which is the value of the test statistics for a test of independence. Next, we will jump to step 5, which is make a decision. Value of the test statistic is 1.199 is less than the critical value of 3.841 and it falls in the null region. Hence, we fail to reject the null hypothesis and state that there is strong evidence from the sample to conclude that the two characteristics, flood area and types of flood water level, are not related.
Next, we go to the third objective, which is 5.3. Compare the means of water level between 5 different days by using ANOVA. So the following table shows about the highest water level reading recorded for 5 days in several states. We have day 1, which is Monday, Tuesday, Wednesday, Thursday and Friday. Next, to analyze the one-way ANOVA, the following is the 5 steps hypothesis testing. So for the step 1, we need to find the null and alternative hypothesis. For the null hypothesis, we know that mu1 must equal to mu2, must equal to mu3, must equal to mu4 and must equal to mu5. For alternative hypothesis, not all 5 means are equal. We go to the next step, which is step 2, because we are comparing the means for 5 normally distributed population. We use the F distribution to make the test. So in step 3, the significant level of one-way ANOVA test is always right tail. So at the area in right tail of F distribution curve, we call it as a rejection region, as I highlight at the right tail of this curve. So we need to find the degree of freedom for numerator, which is 4, and degree of denominator is 36. So from the F distribution table, we find the critical value of F for degree of freedom 4 for the numerator and degree of freedom denominator, and the area in the right tail of the F distribution curve. So the required value for F is 2.634. We can look at the graph.
Step 4. Step 4 is the calculation of the test statistic F. And this is the summary of the collected data from Wednesday until Sunday. And this is ANOVA table, which is we compute the value of the sum of squares, degrees of freedom, and mean squares to calculate the value of test statistic F. Thus, we get the value of the test statistic F is equal to 0.571. In step 5, which is to make the decision, we get the value of the test statistic F equal to 0.571 is less than the critical value of F equal to 2.634. It falls in the non-rejection region. Hence, we fail to reject the null hypothesis and conclude that the means of the 5 population are equal. In other words, the 5 different days do not affect the mean scores of the flood water level in flat area.